Okay, now I'm going to talk for a moment about ground state versus excited state. If I have an electron, let's just say this electron is in this orbital, and it jumps up to this orbital. It will only jump into that orbital if energy is added. And that energy can be in the form of heat. In the case of the light bulbs, it can be in the form of electricity. Now, for an electron to go from an excited state back to the ground state, you have to remove energy, or energy has to be released. When an electron goes from the excited state to the ground state, energy is released, and it's given off in the form of light. Now, each element has its own specific wavelength of light. What you're going to do is you're going to figure out that different elements have different wavelengths, and each one of these wavelengths is unique. So, for example, scientists can look at a specific wavelength of light, or a sample, and they'll see the different wavelengths that light was emitted. Emitted means given off. What they'll do is they'll compare this unknown sample to a list of existing known wavelengths. And what they are able to do is they're able to compare the elements that are present in that sample of light. For example, we have a bright line spectra that we looked at in class. This bright line spectra is just a small portion of all the spectra that is present. However, we could compare this wavelength and find out which elements are present based on how they match up. Once you do that, you identify the contents of the sample.